Let's start the meeting, the event, and let's see what we can do for this. We will have a very interesting presentation, as we have with us two gentlemen, very known and very reputable in the research area, Takashi and Boyan. I will share with you just a couple of words about them. They will be able to share as much as they would like to share about themselves as well in the following presentation. For the logistic part, the proposal is they will present for approximately 1 hour, and we will have in the end a question and answers session. For this, the recommendation would be to raise a hand or to write down in the chat directly, and we will take care of the messages. So with this, allow me to share with you a couple of words about Takashi. Firstly, he is leading the technology promotion team at Entity Research, and his role focuses on emerging solutions like attribute-based encryption. He is very active within hackathons and has an extensive background in research management and the commercialization of research technologies. And towards about Boyan leads the innovation department, focusing on innovations and data safety, privacy and security protection, smart cities and society 5.0. His research activities resulted in over 60 scientific papers published in prestigious journals and conference proceedings, including 5 national patents. Now, the only thing I would add is all the time when I meet people in research area, I'm very curious, and I highly appreciate this activity because it makes me very curious in general, and I admire it. So with this, the floor is yours, Takashi and Boyan, and let's enjoy the event.
Yeah, thank you.
Thank you very much.
Yeah, okay, so let me share my screen first.
Yes.
Okay. Can you see my slide?
Yes, it is visible.
Yes.
Okay, good. Okay, so thank you. So good evening, everyone. So today, Boyan and I are here to discuss a critical topic, that's smart sovereignty. So as we move forward towards the society 5.0, so ensuring the data security, privacy, and integrity becomes paramount. So we want to talk about how to achieve this goal. And thank you for the introduction, but let me introduce myself quickly. So again, my name is Takashi Goto, and I am the Vice President at Entity Research. And as an introduction, my primary role is leading the technology promotion team and exploring the market potential of our research project. And one of our key areas is attribute-based encryption. So I will explain this technology in this presentation. And we believe this technology has significant potential. And before this position, so I served as a director of NTT R&D in Japan, and I managed various research initiatives, and including such maintenance technology for network infrastructure, such as utility poles or optical cables. And okay, so Boyan, could you please introduce yourself briefly?
Yes, thank you very much. Good-san. So my name is Boyan Mrazovac. I'm responsible for innovation department at Entity Data Romania. I'm originally based in Serbia, so we are both countries in one cluster. And basically, as what has been already announced, that we are very much focused on privacy, security, protection, technologies like smart city, actually emerging technologies in the context of smart city and society 5.0. So I'm also very much connected with the University of Novi Sad. And I, besides this regular, let's say, business by leading innovation in corporate, I'm also doing a lot of researches together with the university. And I did also some journal papers and scientific papers that have been previously published. So thank you very much, Scott. Sound back to you.
Yeah, thank you, Brian. Okay, so let me start the presentation. So So this is the background. So we all know that the data breaches are a big problem. So our essential information can be stolen, so no matter where, so that we keep it. So I heard that the damage from data breach is increasing year by year. So it's said that the cyber attack occur every 39 seconds, and also that they cause damages amounting to 9.5 trillion. So we already have ways to protect our data, like using firewalls. But however, so this method essentially surrounds the data with a sort of prison. So it becomes difficult to share and utilize this data with others. And once the prison is breached, the data leaks eventually occur. So this is our situation. But this is where our attribute-based encryption, or ABE, comes in. So ABE offers a more flexible and dynamic approach to data protection, so allowing us to better secure sensitive information in the digital way. So it's not just about building a security wall around the data. So we want allow data to move freely for collaborating purpose while remaining secure. Okay, so attribute encryption is one of the technology of cryptography. So let's start with a basic question. What is cryptography? Okay, so this is our idea that the cryptography is a science of managing, storing, and transmitting information securely, even when it is not physically protected. So actually, this is a phrase from Brent Waters, who is a director of our cryptographic laboratory. And I believe this is a very basic concept of cryptography. So ensuring the security of data in any situation where physical security is sometimes impossible. So, and actually the cryptographic technology is all around us in our daily lives. So even if we don't always notice it, but so let's say, so when we use a two-factor authentication to secure our accounts, so we are using cryptography, and disk encryption protects the data on your laptops, and the Wi-Fi networks is using the cryptographic protocols to prevent the unauthorized access, and the encrypted cloud storage service also keep our data safe, and it's using the cryptography. So these everyday applications highlight the importance of cryptographic technologies. And this is the ABE. So let me explain what the concept of the ABE. So ABE is a type of cryptography, so which stands for attribute-based encryption. And it's a combination of two technologies. So we describe this concept as a one technology with two critical functions. The first is the encryption, apparently, and the second is access control. So we have implemented an access control mechanism into the data itself. So this is a unique tool that protects the data with encryption and make it more usable thanks to the attribute access control. So let me explain how this works. And before talking about ABE, so let's take a closer look at the conventional, traditional encryption methods. Okay, so I will start with the symmetric encryption. So let's say, so using the symmetric encryption, like the AES. So this uses a single key for both encryption and decryption. So this approach is known for its speed and efficiency. So okay, so let's say the Bob want to send some data to Alice. In that case, beforehand, Bob and Alice need to share the same key for encryption to decryption beforehand. And after that, Bob can send some message with encryption and send it to the Alice, and Alice can decrypt it with the same key. So, but this approach is very common. But the problem is that if the Bob wants to connect to others, in that case, we need some more keys. So this is the growing. If the number of users is growing, the number of unique keys is also required is growing. So actually, so we need kind of the order of n squared keys is required. So this is very complex. So for instance, if there are 10 users here, so we need 45 unique keys. And if so there are 100 users, so we need 4,000, around 5,000 keys. So this growth is a significant challenge for securing key distribution and management in the large-scale systems. On the other hand, so we have another crypto technology like public key encryption. So this is the kind of involves a pair of keys for the encryption and decryption. So Alice has a secret key and also the public key. And if Bob sends some data to the Alice, so Bob will use this Alice's public key to encrypt his message and send the message to the Alice. And Alice can decrypt this message using her secret key. So this is the very concept of the public key encryption. And each user can publish their public key, and each user use that public key for the encryption. So this is order the N key description. So this is more efficient way compared to the symmetric encryption. But the drawback is this requires some computation power compared to the AES. So this may be the encryption and decryption slower and less efficient for the large amount of data. But it excels in scenarios where the secure key exchange is critical. And okay, so before that, yeah. Okay, so let's explain how we can improve that traditional encryption methods with ABE. So before talking about ABE, so let me explain the history of ABE. So the concept of the identity-based encryption this is a foundation of ABE, was first introduced in 1984. So this is kind of the single publication key. So in the public key encryption, so each user needs to publish their own public key, but in this mechanism, we only have one public key called the master public key. And this could be used to verify entities. And after that, the first practical ID-based encryption schemas were developed by Bonnet and Franklin and Cox in 2001. And these schemas allowed encryption based on the user's identity, such as email address. So with public master public key and the recipient's email address, the sender can encrypt the data and send the data to the recipient. And after that, the first attribute encryption schemas was developed by Sahai and Waters in 2004. So ABE extends ID-based encryption. So the ID-based encryption can only use ID, but ABE can enable the encryption and decryption based on the set of attributes, and such as roles or characteristics. So this approach allows fine-grained access control and making it highly suitable for very complex environments. So, and let me explain a bit more about flexible access control or fine-grained control of ABE. So as I told you, so this is a conventional encryption of the public key encryption. So this is kind of the all or nothing situation. So we can encrypt the data with public key and decrypt it with a secret key, but this is all or nothing, and it's not possible to show only the part of the data. So in addition, if we want to distribute this data to multiple people, so as I already explained, but you have to encrypt the data separately for each recipient. So it's not efficient. So on the other hand, ABE, so we can generate multiple decryption keys with different access policies. So we can still encrypt all of the data with one single encryption key and bake the access policy into the data itself. So in this case, let's say, so we bake an attribute analytics into these two columns, birth type and type 2 diabetes. Then we will provide the blue key to researchers. This blue key has the same attribute analytics. And then that the researcher can unlock only these two columns, birth type and type 2 diabetes. So we can also provide another key like yellow key. This has attribute, okay, so ABC insurance, and ABC insurance is embedded into these three rows. For that reason, so this yellow key can only see these three rows. covered by their ABC insurance. So this is the beauty of AB. So AB is not protects and transfers the data efficiently, but also provides the access control mechanism to the data itself. So we call this additional layer protection. So ABE provides additional layer protection, and we call this last line of defense. So you may think that access control mechanism has already been implemented by lots of systems, and I think you are right. So, but in traditional models, we protect data at the application layer or hardware layer, like cloud encryption or hard disk encryption. But while these features are implemented at the system level or hardware level, so the data itself is not yet protected. So if the data is moved out of the system, so in the worst case scenario, that your data can be leaked. So if it is leaked in the ABE scenario, so your data is still protected thanks to the ABE. And let's dive a little bit deeper into the specific of attribute encryption. So what is the attributes or what is the policy? So this is attributes. So let's say, so we can utilize the 3 types of attributes, the strings, and integers, and dates. The example of these attributes are like this. So we can use any arbitrary strings or integer like medical, Italian, or age is equal to 20, or date of birth is September 24th. So these are the example attributes. And we have the policies. The policies is basically a Boolean formula of attributes. So this Boolean means that we can include the logical operation like and, or, not, and the comparison operator like the greater than or less than or equal to. So for example, the policy may require the user possess the attribute like medical and also Italian, or simply or Italian, or a more complex version, so we can create this kind of policy. So the open parenthesis L0 or B1, and the parenthesis C and D. Yes. Or we can use a date for the policy. Yes. A key aspect of AB is that the set of attributes satisfy a policy if and only if the policy evaluates to true based on the user's attributes. So for example, the attribute set medical and Italian satisfy the policy. Sorry, attributes of medical or Italian satisfy the policy medical and Italian. So in this case, the user can decrypt the file, but if not, the user cannot decrypt the file. Yeah. And we have 2 types of schema, 2 types of policy way in attribute-based encryption. The first one is ciphertext policy attribute-based encryption. So as I explained, that we have attributes and on the policy, and in this type, so we embed the policy in the data itself. So let's say this policy to find and this data should be viewed only a director of VP of R&D and can access this data. And the data is encrypted and the policy is also included in the data. And after that, the data is distributed to the users. And if the user's attribute meets this policy, so they can decrypt and access data. So in this case, that's okay, I can see this one. Yeah. This user has the attributes R&D director, so she can unlock this data, but this user doesn't have the attribute director for that. So in this case, he cannot see this data. So this is the CP ABE. And we have another type of attributes, key policy attributes. So in this case, that's key itself is embedded into the key, policy is embedded into the key. So let's say, but the attributes are embedded in the data itself. So let's say we embed the attributes like for the movie data, like so comedy, American 1980s. And after that, we distribute this encrypted data to the users. And the user has the key with the policy like comedy and American. So in this case, this user can decrypt the movie data. But as a user, like let's say the Italian and the comedy, in this case, this user cannot decrypt the contents itself because the policy doesn't match the attributes of the data. So this is another type of ABE. So ABE has two types of policy, the key policy and ciphertext policy. So we can use this type, so based on the requirement and the implementation. So this is the very basic of the ABE. And in the past decades, this ABE technology has been significantly growth within academia, so including the quantum resist cryptography. But imagine that so finding this random key on the ground, it's useless to you. So you found the key, but this is not used because you don't need the door. So this was the state of the technology 2 years ago. So we had a key, very essential key, but like a key on the ground, so we had no idea how to use it. But now we know how to use it. So we have progressed from cryptographic research into reality. So we've created a platform where it's easy and simple to use the technology and the surrounding components, where as an application or a system. This achievement is not just a result of research, but also thanks to the collaboration work with Boyan's team. And let's talk one example, so called SPIP, developed by NTT Data Romania, led by Boyan. So this packages three key privacy enhancing technology. The one is the ABE, and the others are data anonymization and multi-party computation. So ABE can protect the data, as I explained, and anonymization can sanitize the privacy data for analytics, and multi-party computation can provide collaborative computation for very sensitive data in a secure way. So we are providing easy-to-use platform to protect the three critical areas: security, privacy, and integrity, and supporting a wide range of use cases, so such as data sharing or zero trust and more. So let me explain what the data anonymization and multi-party computation is. Okay, so anonymization. So this technology can process data using a variety of technology developed by NTT. And one key feature is the ability to evaluate the balance between anonymity and also the data usefulness. So ensuring that the data remains variable when protecting the individual privacy, sensitive data. Okay, so the process begins with the collection of the personal information, and such as patient ID, health insurance number, names, and addresses. So this information is very sensitive. Then we want to anonymize this data, so removing identifiable details but retaining essential variable data. So for example, we replace the patient ID with a random but unique ID, and we remove the very sensitive data like names and insurance ID. And instead of using the full address of the patients, so we keep the information only up to the city level, such as Boston or Seattle. So we don't have age column here, but if we have age column here, so age is grouped into categories like 40s or 50s. So instead of using the actual age. So this anonymized information can be shared with others because now there's no sensitive information in the data. So we can use the data for analyzing or other purposes without compromising the privacy. So this approach helps organizations handle sensitive information while maximizing the data value for analyzing and decision making. And this is MPC. And MPC allows the computation on data without disclosing the actual data. So this means it's kind of a magic. So you cannot know what the original data is, but still you can get the computation result. So let me explain how this works. The first, let's say the user A and B has the original data 100 and 80 respectively, and these data is fragmented into pieces, and the server and server process these data. Let's say, so this server just adds the piece of data, 10 and 30, and calculate the sum of these data, the 40. Okay, and the same apply to each server. So each server cannot see any other server's data. So by finally adding up these all calculated data, so let's say 40, 60, and 80, so we can get 180. So, but you can get this total number of original values, but you can't see the original values of users. So this ensures that even if the data is intercepted, but it is a fragment of the data, so it cannot be reconstructed for the original data. The result of this data calculation are provided to data analysts, and we can only see the computed result, not the original data. So this method ensures a robust security to block unauthorized access to the original data and maintain the confidentiality of the data throughout the calculation process. And I want to explain, so these are the technologies, and let me explain some use cases. So Zero Trust Architects extension with ABE. So how that MTT can utilize this ABE and other technology to provide the customers as a real use case. So Zero Trust Architecture, the concept of Zero Trust Architecture is very simple. So every time you want to access the data or resources, that the access should be authenticated or authorized every time. So even in your network of company's network or outside network. So whenever you want to access the data should be authorized. But the pain point is that once the data is from this system, the data is not protected anymore. So for that reason, so we implement ABE to extend the Zero Trust Architect framework. So if the user want to download the data from the system automatically encrypts the data with the same schema as same policy as the online system. So thanks to the ABE, even in the cloud or in the local environment, the data itself is protected, and also the control, the same control, access control in the ABE. So this is kind of the extension of ABE. The data can be stored in any situation in the cloud environment, but still the data is protected. So this is a kind of the extending of the Zero Trust architecture to the data itself. So, and this is another example. So we can protect the data, and that's not limited to the structured data or text data. So we can apply the data to the image or video. So this is an example of the use case. So this is for the surveillance camera images. So we have lots of sensitive data in the image. So we have people's face, license plates, and text. So our application can detect such sensitive information using AI and encrypt the sensitive part with attributes. Let's say that we can encrypt the people's face with the attribute face. And we can store this data in the cloud. And after that, we can provide the proper key to the user. So let's say this user can only see the text with the attributes text, and this user has the key with the attribute face. In this case, that user can see the people's face, but cannot see any other sensitive data. So this is the beauty of ABE. So we can provide only one encrypted data to the user, but we can control how to utilize the data based on the decryption key. So this is a very efficient way to provide encrypted encrypted data to the users. So still protecting the privacy information. Okay, so this is the image of encrypted data. So the vehicle and the peoples are encrypted and blurred in this case. But if I have the proper key with the license plate of the vehicle or people, so I can see the whole data in this. By the way, actually, he's the developer of this application. Okay, so that concludes my explanation of ABE. So I have explained the fundamentals of AV technology and its basic operation and benefits. But I hope you now understand that this is not just academic technology, but that there are already use cases like this and system leveraging AV. So now I'd like to pass the baton to Boyan. So he will explain further now how these technology form a solution to build the sovereign environment. So please, Boyan, please go ahead.
Thank you very much, Goto-san. So thank you for explaining the attribute-based encryption and what it is actually, what kind of technology is that. And I would like now to put this technology in the context of smart sovereignty, because this is the concept and this is the vision that nowadays, not only inside of European Union, but practically worldwide, most of the countries are trying to adopt, because we need to improve citizen services and interaction between citizens and services, but still we are very much bounded by different regulations and different legislative framework, which all requires that any type of information exchange between citizens and any type of state service must be secured. Personal information must be secured, and they must be secured not only while they are stored somewhere on the cloud. Also, they need to be stored on the cloud in a limited time manner due to the GDPR and other regulations, but they also need to be secured, even being transferred between different spaces. A big now move within European Union is toward European data spaces, which means that we need also to be sure that the data can be freely transferred from one space to another, preserving the same level of security that it had when it was in the original space. And this brings us practically to try to imagine now a future society which will very rapidly bring any information to the citizens in a right way, which will provide accessibility from wherever the citizens are trying to access to the data, but at the same time, they will be very user-centric, which means that this sovereign identity that is practically one also of the technologies that is providing secured and centralized access to the personalized data. Citizen rights to manage their own personal information will be practically met. So the technology that we are providing here, and as Goto-san mentioned, this is not just the research technology, this is also the technology which is practically now being exploited by the market, should provide security of the data wherever data remains, legality of the data, so we are sure that the data follows certain standards like NIS2 regulation, which is very much a hot topic everywhere nowadays in Europe, but also possibility to interconnect with different services, and at the end, the trust of the data. So when we say privacy, security, and integrity, especially from the integrity point of view, we think and we believe that the integrity means that the data that is stored somewhere is really the data that the user or anyone else who was the data owner stored at that place. So this is not injected data, it's not poison data that can change in future further decision-making process, or the trustworthy of a person or the collected data itself, but the data it's really protected and it's trustworthy. And that's very important, because that way we can guarantee as one system that this smart sovereignty for society 5.0 will be met. So if you go to the next slide, basically what we are expecting nowadays from the systems that exist are at the first stage digital experience. So now we are speaking about combining different approaches in different areas. We can speak about public services, we can speak about financial services, we can speak even about manufacturing, because in manufacturing there is also a lot of data coming from edge devices or from sensors which need to be processed and which need to be stored in a secured way. There have been several different proposals, but each of them could lack in certain point with complete solution, like for instance, blockchain or secured environments, because as I said, and as what Goto-san presented, attribute-based encryption brings something that other technologies maybe are lacking, and that's the possibility to preserve the same set of accuracy and the same level of attributes that are embedded with the cryptography, with the crypto technology itself on the layer of data. And practically now our data is protected on the lowest level. So we are not speaking anymore about debug systems that you can access the data through logging into the system and practically following the rules that are defined on the layer of the application itself. Now the rules are stored directly with the data, and practically what we are providing with the data, the protection is embedded all together. And in that case, the data that we can now provide and that the data owner can control provides completely new added value, because if we are speaking about this new protected data, data is safe and secured. Data can be monetized, because nowadays when the user are using this type of the data and the technologies that Goto-san presented to you already, practically the data owner can decide what part of the data in a fine-grained way can be shared with third parties. So the third parties, like maybe some research institutes, can use, for instance, medical records of the patients without touching any of the personal sensitive information from the patients, but maybe they can see, for instance, the correlation between different types that can help them to improve further researches and to support, of course, further medical development. So practically we are here finding, and we are creating a kind of secured environment which is following zero trust architecture regulation and requirements, and we are providing that now even a bigger community can exchange data in a secure way and can benefit from the data. So basically, if you go to the next slide, this is, besides improving complete digital experience and the flow of the data, it's also very important, as I said, the data trust. So on one side, we have standardization of data usage, which is coming through different legislative framework, requesting different privacy acts, GDPR, at the same time, DFFT, DORA, and NIS2 directive. And on the other side, we have enterprises and citizens that want to share that data, but they want to share and utilize data with ownership and with exact knowledge when, how, and why my data is used. And if I don't want to share my data, I will protect my data. And this is where we are getting to privacy data protection, protection from data leakage, wherever data remains, on server or in transit, use of the data with consent, sharing data across different ecosystem, and that is very close to what I mentioned now, the new move towards European data spaces, personalized and optimal services, and at the end, collection and analysis that can be completely controlled and that can bring completely new added values to the data that has been previously collected. Still having everything put in place and having trustworthy data that we know that privacy, security, and integrity in a manner that the data owner decides will not be breached. So when speaking about this data trust and when speaking about government influence, we can speak about in our next slide what actually data protection priorities and challenges nowadays are. As I said, privacy regulation is now getting a very big movement. We are all aware of NIS2 directive that will practically request that cyber security hygiene and different cyber security practices will be put in place, and the deadline for the strategical decisions is practically this year in October. If you're speaking about other existing privacy acts, they're all present and they're all already in use. So data breaches on the other side, when they occur, they are more and more costly nowadays. So we are all now witnessing collecting a large amounts of data for different purposes. We are also witnessing now a great boom on the market, speaking about generative AI and similar types of data processing algorithms, which are of course requesting to have secured prompts, secure data through which it can learn. And everything is moving us that practically the very next important topic, not only regulated, but also requested from the market will be how now the data that has been previously collected, we can protect and we can guarantee the trustworthy of the data, because if you want to train machine learning model, We need to know with what we are training it. And we need to be sure that no one did any type of poison injection. So when we are speaking about poison data, it's the data that is not easily traceable, the data that the third party can inject intentionally or unintentionally, but it can completely break the accuracy of the model after it is being trained. And in order to provide that collection of the data and storing of the data must be controlled. And that's why we are speaking about different priorities and challenges that we have as practically organizations that are having certain responsibility how to protect data. But if we put it on a level of the whole world, at the next slide, we can practically see that we are not proposing something new in terms of regulations and how we need to deal with something. Practically, the regulations are already there, and they are everywhere in the world. We have, of course, everyone know about GDPR in European Union. We have CCPA and CPRA in California. We have in Canada and Quebec. They have their own GDPR. There are also many other states in North America that are practically in the process of adopting, or they are practically preparing to adopt acts that will practically be applicable to their own countries, to their own states. In the East Asia and Middle East Asia, also cybersecurity laws and cybersecurity data protection laws are put in place, and they're all considered. So practically in the next 5 years, 5 to 10 years, we can expect that this market and the trend of privacy will be very much regulated. And according to that, the security of personal information, but not only personal information, we can speak about practically any information which is considered as confidential and sensitive. Security of information like bank transactions or money flow or some special formulas or research is being done, or even data that collects some very sensitive information about devices, how they're operating. It will all require a certain level of security, and this is why definitely the trends on privacy regulation are practically in line with what we are currently doing around attribute-based encryption and other technologies in the same scope. But if we go to the next slide, practically the most important thing, and this is the most critical regulative, is NIS2 directive, because NIS2 directive is requesting that by 17 October 2024, it means this year, all member states and practically all European Union countries and countries which are practically going towards membership to European Union, they need to transpose NIS2 directive into applicable national laws, meaning that starting with October, national laws will have certain articles that will request to have this NIS2 directive already applicable. And then we'll have a lot of new requirements coming from the states, from the European Union, but also worldwide, which will require us to be ready. And we will be ready if, as I said, cybersecurity is treated in a much higher way, and the importance of adopting technologies, new technologies like ABE, but also legacy technologies like what Goto-san presented, symmetric or asymmetric types of encryption, the very simple one approaches, it will be requested. So we will need to follow the rules and we will need to protect the data. Now it's the question, what is the optimal way to protect data and what will be the optimal way in future to transfer data and to operate with the data. And this is why we're speaking how actually attribute-based encryption can be adopted and how attribute-based encryption can support this further integration. At the next slide, I can explain that practically what is expected from us, and that's to put attribute-based encryption in a zero trust environment. So according to NIST that published zero trust architecture, that is, I can say, a pretty reasoned explanation, pretty reasoned strategy how zero trust architecture should be formed, because it dates practically from since August 2020. We see that the general model of zero trust environment can be very much extended with attribute-based encryption, key generation, and attribute-based encryption functionalities. Because if we are speaking about how data is being stored, if you are in perimeter-based security environment, so once you confirm and validate your identity, you will get access to certain context and certain environment. Practically in that environment, then it's up to user to behave properly. Otherwise, that user, if it's not a regular user, it is someone who tries to hack the system, they will be able to make a lot of damage. But if you are speaking in zero trust security environments, with practically once someone identifies the identity and confirms the identity, then even the subject getting towards the system will have constantly untrusted environment, untrusted context until policy enforcement point and policy engine, so practically policy administrating unit, enhanced with attribute-based encryption, because it's important, as I said, it's embed the encryption with the data itself, so data doesn't remain anymore as a ciphertext. As a plain text, it becomes ciphertext, and it's not anymore in a raw form, it's in protected form. Then and only then, if user satisfies the policy enforcement point and satisfy the set of attributes and policies that got us unpresented, then the user will be able to access to resources which are assigned to that to that user. And zero trust security model, in that case, it requests data to be encrypted at rest and in transit before moving to cloud storage from other devices, from other clouds, or practically from any edge devices which are filling the data to the cloud. So in this case and in this environment, even data breach occurs, even with limited access to the data, no one can really read the data except the intended person, the person who possesses the right attributes and who possesses the right policy, which practically combines attributes in a nice way. What it means if we are putting it into the context of a more comprehensive platform. So if you go to the next slide, we can see that practically what has been already announced, security, privacy, and integrity protection, SPIP concept, is, let's say, a cloud system. And this SPIP system is enhanced with capabilities like attribute-based encryption, like data anonymization, multi-party computation, but it also provides, for instance, access through secured approach for biometric-based user authentication that combines biometric authentication, which is done on a cloud. So we are trying to move secure authentication from the edge devices to the cloud in order to provide more security, because while we are in controlled environment, we have more trustworthy to that environment. And basically, once the user confirms the identity using biometric data through the identity wallet, which is very much close to European EID initiative nowadays, that user can have access to the data because his or her attributes are something that we can extract from the wallet. And if you take a look here, the overall concept of security, privacy, integrity practically provides different data providers to collaborate together to practically upload the data to federated space, to centralized data space, and they don't need to be worried about how their data will be protected, because data with fine-grained access control will remain protected wherever it remains. Only if you possess, again, the right attributes, you will be able to access it. But on the other side, analytic results with fine-grained access control can be achieved with multi-party computation, because if information consumers wants to access data, if they possess the right set of attributes, they will be able to see that data which is assigned to them. If they possess the right set of attributes and identity, they will be able then even to query the data and to extract certain statistics over the data. So they then don't need to see the complete records, for instance, of medical patients somewhere in the hospital, but they can extract statistical information about certain diseases, how they're correlated with age, with any practically type of medical information that can be extracted there. And this brings us exactly to the situation that once this data is being protected, sanitized, and also cleaned, we can further enable this data flow to third-party institutions, to research institutions, where they can extract exactly the information that they need without touching any sensitive information. And then this solution, what you can see here, is something that provides practically, if you go to the next slide, please, at one level, the data trust policy. Now we are speaking about more comprehensive data governance from the security point of view, with access policies and the possibility to share data to the data disposal. So the data now is under control during the whole life cycle, from the data generation to the data disposal, because we can control it even with a timed key or geographical location key and similar. We can accelerate data gathering because once we provide possibility for different third-party institutions to collaborate together to practically provide the data, to gather the data, and not to be worried about how these data further will be treated, it will definitely provide a completely new boom on the market, because now everyone will be really able to collaborate together without any worries how their data is, if their data is going to be misused. At the same time, as I said, secondary use of the data, so data monetization, can be enabled with this technology. And at the end, the biggest concern that is coming now with this new quantum era is how we can protect data from quantum attacks. This is what we are taking care as well, because attribute-based encryption now and the research around attribute-based encryption will provide completely new standards of set of bytes that can even prevent from quantum attacks. So the data being protected from quantum attacks now definitely will be protected during the whole life cycle. And this is the general concept, but I must say this is also the product that Entity Data Romania, together with Entity Data Research and colleagues from Entity Data Inc., delivered. And as we explained, the background of the technology is with attribute-based encryption and other technologies that we mentioned. But the main and the important thing is that this practically solution now provides a different set of very horizontal use cases, which are not just focusing to one vertical, to one industry. This is really a platform on top of which different use cases can be delivered. Imagine a use case, for instance, when where in a corporate or in a bank, on the level of the company, you can read attributes of all employees, and you can then control how the documents or how the contracts will go without having any worries if this contract will be taken out of the corporate level, or if someone who should not have access in the corporate level will be able to see the document. And this is what attribute-based encryption and SPIP technology can provide. If you go to the next slide, I can just explain also some use cases. For instance, how to enable secure digital citizenship is also very important. And one project that maybe people that are visiting us and that are watching us today here heard about, the Cluj ID, is a platform that provides a combination of attribute-based encryption with secured authentication. And secured authentication provides, for instance, the citizens in Cluj to access different services, and their data is staying protected. So how it is done? Exactly using the technologies that we explained. You can imagine, for instance, the identity card. You can possess the identity card. It can be stored in the identity wallet. It doesn't have to be stored in the identity wallet. The important thing here is that the original data is getting encrypted. So even if it is stored on server, it will be encrypted. And practically you can completely digitalize your approach, how you're using your data. And then different authorities can have different keys. One authority can be enabled to have, for instance, a decryption key for driver license. And when they request on demand to see who you are, practically the exchange of certain data from smartphones only can definitely enable that party to be able to see only the data which is assigned to them. In this case, it's driver license number. Then decryption data, decryption key, for instance, face or date of birth, as what we explained, these technologies not only targeting textual files, it is also targeting binary files, MySQL, structured and non-structured data. We can practically control even if we want to show from this document, if we are having the proper set of attributes and the key generating on top of these attributes to see the face of a person, then the face of a person will be enabled. This is, for instance, one type of the use cases. Another type of the use cases is, as I said, very close to what we presented as a ClueJD, where practically now with this approach, you can validate your identity utilizing facial scanning, and your identity can unlock access to different services like tax payment or service for paying the parking spot, or even we can enable now a completely new service that helps citizens to express their votes and their opinions about certain public matters through the voting platform. With this voting platform, you can completely anonymize citizens because we know exactly that the person that did the registration, even we don't know because that person is completely anonymized, is the same person that is trying to access now to the data. But we combine different technologies like attribute-based encryption, like privacy-preserving biometric authentication, utilizing homomorphic encryption in the background with identity wallet, and we can provide a complete flow that we know that the person who is voting at this moment is the right person who did the registration, but we don't know who is the person. The only who can know who is the person is practically the public authority because they have list of citizens with all the personal data. And we can guarantee that the citizen that exists in that list is the same citizen that did the registration, although we don't know who it is because we are exchanging some hashed keys, and based on that we can understand what is happening and who is the real person. And that's one of the very big use cases, which is practically utilizing this technology, but not alone, because as you see, we can combine attribute-based encryption due to the fact that it's very horizontal technology, even with other cryptography technologies to achieve different, very different set of use cases where, for instance, secure authentication in this case is also very sensitive, relevant, and important for the end users. So I mentioned about digital identity, and this is a very important concept nowadays. We are aware that also on the level of European Union, there is a new standardization team under EPSI standardization group, which are trying to set standards for digital identity wallet. So what is practically digital identity wallet? It is a kind of technology that provides authentication, verification, and validation of special information sets called verifiable credentials. So practically verifiable credential in this domain of digital identity wallet can be anything. It can be even a personal ID card, a passport, or it can be any set of information and attributes that are assigned and personalized for a particular user. Identity wallet contains all the information, and practically when you confirm your identity and you get access to identity wallet, through identity wallet you can also have certain possibility to access different documents. If you want to extract your document from the Katastar, and you should be the only person who should have access to that, or to certain documents and contracts which are stored somewhere on public services, and you need to validate and authenticate yourself, there is a traditional model of doing it with different tokens, etc. But this is much faster way of doing it, because at the same time, if we are speaking about identity registration and validation, there is no requirement for a manual validation on the edge, on the server side. So we can do everything much faster, because now we know that, again, the user who is using this system is the one who practically did the registration, and during the registration his identity has been already confirmed because the public services confirmed that the person that's trying to do that exists with all his attributes and information. And this is the way how we are now trying to enable municipalities in Romania. At the first place, the municipality for the city of Cluj, how to be able to enhance their citizens to be really more digitalized. So, like, imagine students that will have certain discounts wherever they go, or that will have a possibility to use free public transportation, and they will not need in any moment to show any identity to maybe some personnel that is not authorized. So in some countries only police authority can request for the identification document, but you cannot always ask police even to check the tickets in a public transportation. But if we are using this platform, it will be way easier, because the real identity, the personal information will be practically hidden, but the guarantees for that person in every moment will be achieved through the application that is now called Cluj ID and that is used in the city of Cluj. So practically, I'm speaking a lot about Cluj ID, but let's see what is Cluj ID, because I think some people heard about it and they would like to understand it. So Cluj ID practically combines different technologies. As I said, this is mostly identity validation platform and protocol. It combines technologies like homomorphic encryption, like artificial intelligence for recognizing user, for protecting from anti-spoofing using different types of algorithms. It also combines attribute-based encryption and identity wallet in one platform. And that platform practically provides reliable user identity validation alongside with privacy protection. Because we say GDPR here is still very powerful legal framework that we need to follow. And we need to provide users the possibility to remotely and digitally interact and still keep their own personal privacy. So if you go to the next slide, this exactly explains. So the citizens first register for public services using Cluj ID. And it is a combination of video-based identification and identification using valid document. We will not store any personal information anywhere, even the valid document. We are just reading information that will help us to identify the user and to correlate that this user and check that this user really exists somewhere in some database using the same ID calculation. The City Hall issues, upon the correct registration, the verifiable credential for the citizens. And then this verifiable credential can be for one service, it can be for multiple service, or it can be for each service, different types of verifiable credentials, which are practically a possibility and a kind of a key that unlocks access to different services that one or several institutions are offering. So you can have, for instance, verifiable credential to access, as I said, Cataster reports at the City Hall, or you can have even another verifiable credential, which doesn't have to be aligned with the City Hall. They can go to the hospital and you can practically enter the hospital because your personal information, your complete identity is now connected and will guarantee that you are the right person who is seeking for medical help. Or you can have completely another verifiable credential, which will provide you access to some places like cultural places, museums, galleries, concerts, or even it can provide you practically to access or to use public transportation, because in this case, the verifiable credential for public transportation can be assigned to you in your identity wallet. And then Cluj ID, practically once being issuing the verifiable credential, it will also every time user needs to authenticate himself or herself, he'll first confirm his identity by using facial scanning, fingerprint recognition, and any other type of biometric data. It's no matter which, and will be able to access his or her own private personal identity wallet. Once the identity wallet is accessed, then practically all the attributes which are assigned to that verifiable credential will provide access control to that user, and that access control will not be on the application layer, it will be on the data layer. And this brings us back to exactly the main purpose of attribute-based encryption, because now attribute-based encryption on one side is technology that protects data at rest or in transit all the time. And on another side, we have secure authentication that merged together now gives much bigger security approach. It automates the complete process from the registration to the login, and it provides also anonymized way how certain information, or it doesn't have to be anonymized, but in our case, practically everything that Cluj ID knows, it knows only that there is a right user, but we don't know who is the user. And we will give to that user access rights because we know that in verifiable credential for that user, we have these attributes which will practically provide this user to be able to access to the services or documents which are assigned to him. And this is what Cluj aims to provide. So practically, at this stage, we are having Cluj used already for accessing to, as I said, tax payment services or services that are assigned with certain applications like paying a parking spot for the whole year and similar. But in future, it can be extended practically to any other service, even for the communication between different municipalities. So different verifiable credentials can be issued to a same person, and maybe a person who is not resident of one municipality with his or her verifiable credentials from other municipalities can have certain possibilities and certain rights, even being someone who is maybe not the citizen of that concrete municipality, but still with his or her attributes will have much bigger possibilities, and at the end he will be able or she will be able to automate everything, which always is one of the bottlenecks, how to speed up secure processing of the data on the level of some services and how to get the data really as fast as possible when users need it. And that is what we want to achieve. So if you remember from the first slide when I started presented, how to make a user-centric, trustworthy environment where the data will be fastly achieved and fastly reached, and how that environment can really improve the interactions between citizens and public municipalities, public society 5.0, or banks, or hospitals, or any practically other institution where you need to show up your identity. This is what we want to achieve. And that's why this technology is something that practically we are not considering, as Goto-san said, only emerging cutting edge technology, but the technology that really finds its usage in everyday life. And that would be practically the introduction of the use cases and how we are using it from us. I think we can now switch to Q&A session, and if you don't have any sessions, or if you would like to follow up with us for more information, here you can find the emails and you may contact us whenever you want.
Boyan, Takashi, thank you very much for the presentation. I was concerned, I was worried at the beginning that I might not have some questions, but I think that the topic is so complex. We can discuss about it days. It's fantastic. I would invite everybody if they have any questions to raise a hand or to write down the question within the chat, and until the first participant will start addressing if there are any questions. I can choose from my list. I will start from the end towards the beginning, and I would be very curious. The business cases, the cases you are talking about, are they only hypothetical, or you have already some real cases? Are they feasible?
Yes, thank you for your questions. I can answer right now. They are very feasible. As I said, one of the use cases very close to us is practically at the city of Cluj. So this is where we have a very first use cases for the citizens that can now access to certain city hall services by using this technology. But this is not the only use case, because we have a lot of use cases that we also adopted, especially in Pacific region, In Australia, for instance, we provided a solution utilizing the same technology for the university network, where they can now exchange different information between themselves at one university and practically distribute it between different universities. We have also some use cases where we deploy this technology for centers for improvements in sport. So practically organizations and companies which are doing a lot of research, medical, statistical research in sports, and they want to stay also secured, and they want to be able to, in a fine-grained way, control the flow in the information further. This is also one of the installations where we did it. And we have a few other that we are discussing. Some of them will be on a public level. Some of them will be also with some banks, how the data can be protected within one bank. So different contracts, practically you can imagine that roles of executive board, they can see one type of the information or one type of the contracts. Others should not be able to see it, or they should see it in a different manner, maybe not complete contract, but just some paragraphs. These are all the topics and use cases that some of them we already deployed, and some of them we are now developing. So to your question, this technology is not only hypothetical, this is something where we really have a real use cases, and we are growing now more.
Excellent. I can build a bit on this because you made me curious with this Cluj idea. I guess we are talking about the city in Romania, yeah, Cluj and
City in
Poca.
Romania, that's correct.
And prior thinking or prior judging where this is located and start building on this, my first thought would be such a solution, which sounds very good, and I don't have any doubt about, let's say, compliance with the regulations, because let's say, as per the information you provided, everything is in line with the requirements, which are more and more present in our lives, and they will still come. But I would think that implementing such a solution would require a high level of maturity of the entity, of the organization, of the society, of the area where you propose such case. Now, being living in Romania, it is true some cities are more mature or more open or more flexible or more curious comparing with the other ones. I would be curious how the conversation with the city hall in Cluj or with the institutions in Cluj has been conducted, and which was the feedback you got, because my personal feeling is that we have still a lot of work to do in terms of uniformization, centralization, digitalization in general, at least in Romania.
Yeah, that's right. Basically, knowing that this year, actually, the next month are the elections in Romania, I will try to be very neutral. So
Sure.
I wish luck for everyone, so better wins. But practically, the current organization, the city hall in Romania, they recognize, and one of the strategical goals on their side was to adopt new technologies that can definitely provide much higher level of digital transformation. I believe that you heard about systems like Antonia and similar that are adopted in the city of Cluj, and they're very much looking forward, because what they were looking for is to try to engage more citizens into the discussion with them. So every society to adopt new technologies, they will have certain resistance, and especially speaking about protecting personal data, people will always have certain untrust because of some examples that even in the last few years we witnessed that there have been huge data breaches happening also to large corporates, which should not be the case. And once we started and try to present to citizens that they can really bring some benefits. It's not anymore just, okay, we are protecting your data with new technology, then it's fine. No, with this technology, with this use case, because as I said, again, SPIP and AB are part of the platform. On top of that, we deliver use case. But if we say that now with this technology, you will be able to use some services that were not able to be taken before because they requested either a lot of manual interaction or they need to have a lot of consent giving, etc. If we can automate it and we can stay in the boundaries that are coming with the legislative frameworks, we can then open completely new possibilities for the citizens that they can really actively participate and engage with different services, and even they can support public structures for some general decision and opinion making. So imagine, for instance, a platform that provides and collects voting voices from citizens in a secure and anonymized way. So the city hall can ask citizens how they would like that, for instance, some parts of the budget should be spent. Should they be invested in one type part or another or the third one? And citizens can freely give their opinion. They don't need to go to the city hall to sit there and wait when the voting moment starts. They can do it remotely. They can do it in any moment, and they can always be sure that that's them because they will validate their identity. Or imagine also some use cases where you can use the benefits of, as I said, public transportation for elderly people, free public transportation. They will not need to take always their identity cards and be worried if someone who is checking their identity card to validate if they're really retired or not. They will just be able to show, okay, this is the QR code generated for me. Please scan it and you will see, yes, it is correct or no, it is not correct, the time the person who can have a rights of doing it. And this is all something that, as I said, always done in real time. So authentication and validation is done with the exact person at that moment. And this is the moment where we can then say, now we have a complete list of new services that we can open because the security level is not now much higher, and the possibility to automate a lot of operations is now bigger because the process protects the user and puts the user in the center of everything. This is what is the main purpose that we wanted to achieve.
Excellent. Thank you very much. Any other questions in the audience? If not, I would have a final one. You know, I'm not a specialist in cryptography. Based on my limited knowledge, I remember in the beginning of attribute-based encryption, there were some disadvantages, and that's why, or back then, and that's why this was not this didn't become a very popular standard. I'm not sure about what happened since the beginning to present. And actually, the question would be if you'd be very, very critical, or which would be, if any, a disadvantage of using such type of encryption. Are there any disadvantages, or is the hidden secret of the digital encryption?
There's no hidden secret, but yeah, I may say that the one of the disadvantages is the performance, because AB is involvement from the public key encryption, and it is a little bit slower compared to the symmetric key encryption. But so these days, our researchers create the faster AB schema. So in the past years, the AB is evolving year by year, and now we have a faster schema for that reason. So I think so we can now utilize AB so in the real world, not only for the academic field.
Okay, should I take this answer as a general one, or this is the answer for the organization where you lead the research department? Meaning, should we expect a huge development of this area in general, or this is a niche you found and you dedicated your time, and the outcome is a very good one?
Yeah, I think this is a general purpose. So not only for our researchers, but all researchers are conducting research for the faster or more secure attribute-based encryption. So as Boyan mentioned, that in this era, the quantum computers is popular, so this current ABE or other public key encryption might be broke, but the researchers now conducting the cutting-edge research, so try to register such quantum computer. Even if the quantum computer has developed, that cryptography is not blocked. So that's kind of the research are still conducting. So the ABE is now still evolving year by year. So this is not only for our issues, but this is a general, general progress, in the ABE field.
Thank you very much for the answer, and thank you very much for the presentation. And in case there is no other question from the audience, I would propose to wrap up and close the meeting. And in case you would like to share the material, you can share it with our team members. However, the entire presentation will be uploaded within our YouTube channel. And I guess with this, we can only keep in touch. Wish you luck. And it was a real pleasure to be today with you.
Thank you very much.
Thank you very much.
Thank you.